Why does your bike move you along so much faster than walking or running? The answer has something to do with circles. If you look at where your feet pedal the bike, they are moving in small circles. But the pedal is connected by a chain to the back wheel, which turns in a much bigger circle. So as you pedal in small circles, you will turn the back wheel through a large circle, and your bike will move forward the distance of the entire outer tire. If you want to know how far that is, you can cut the tire in light flat. Measure the length, and you have the distance that you will travel for every turn of your wheel. Luckily, knowing a bit of math about circles gives you a way to solve problems without actually cutting your tires. Start with the back wheel. The perimeter formed by the outer tire is called the circumference. Each spoke of the wheel is a radius that runs from the center to the edge. Two radii in line through the center make up the diameter. In all circles, there is a dependable relationship between the circumference, the diameter, and the radius. The diameter of a circle is always twice the radius, and the circumference is always just over 3 times the diameter. And by just over 3 times, we mean the number pi, or about 3.14. Knowing these relationships can help solve all sorts of circle problems, even with circles as big as Earth. We all know that Earth rotates once every 24 hours. This gives us our 24-hour day. Now picture a point here, the equator. If you follow the point on the equator over the course of a 24-hour day, all the way around and back to where it started, it will have traveled in a large circle of about 40,000 kilometers. That makes the speed of Earth at the equator 1,670 kilometers per hour. Compare that to a point way up close to the North Pole. Imagine the point is very close to the pole, so that the circle it travels in a day is only 24 kilometers in circumference. That gives it a speed of only 1 kilometer per hour, thousands of times slower than at the equator. This makes sense if you picture Earth as made up of slices of flat circles, like so. The circle at the equator is so much larger than the circle near the pole, with a much longer circumference. So the point at the equator has to move much faster to rotate fully in one day. That fact comes in handy if you're trying to blast off of Earth and you want to use the least amount of fuel. You can take advantage of the extra speed of Earth at the equator to give your rocket a boost. You just don't get the same boost in speed at the pole. So if you were building a launch platform anywhere on Earth, the smartest place to build it is at the equator. And that's exactly what these clever people did.